and no choices that were taken by the four of us. We had it automated on Google Drive. Also, on the academic side, we had our certifications there and our minor courses, the courses that we needed to complete the course. All of them are also on Google Drive.
And we also took advantage of some video conference technologies such as Google Meet and Microsoft Teams. These were used mostly for the Scrum ceremonies, for the sprint reviews, sprint planning, and also in some occasions the daily stand-ups.
Here we can see our Drive folders, each folder has its context, and all the work that we've done during the past year is saved here. We could also check the meeting recordings where we recorded every single meeting that we had with Oscar, which is a really important tool. Also in retrospective, because when one is working during the sprint, it's really worthwhile to go back and check what the team talked and discussed in the past sprint.
We also need to mention Slack because when the pandemic started, we were in the need of using another collaboration item besides WhatsApp and Google and Microsoft Teams. That was the top tools that we used. In Slack, we had a daily bot automated for us, and we also had Slack as a notification service for us when pipelines had failed.
One fundamental part of developing a platform is where to put the code and how to manage it. And as the code base starts growing and also the teammates start getting involved in the code, it is important to have source control. So that's why we decided to work with different source control technologies. One of them is GitHub. GitHub was the technology we use for our master repository and also for the repositories of all of the microservices. And this master repository also has a consolidation, which we're going to show in a moment. For Bitbucket, we used it for the front-end code and all of the integrations with the other technologies.
And then we also use GitLab and Azure Repo for all of our backend code. We used at first GitLab because it was the best repo for the integration with DevOps. But then, as we go through the sprints, we needed to create a pipeline in Azure. So we migrate all the code to the Azure repo, so we can have like a better integration with the pipeline and the Azure repo.
So as Jose said, we had GitHub as our master repository in which we synchronized the other repositories from Azure, from Bitbucket, and from GitLab. We are going to see later how we automate this process using Jenkins, but it includes the manual pull from each repository and the push for here to GitHub.
Here we can notice that there are only 17 commits because this repo only was committed when the others changed into the master branch. But in total, we have over 400 commits. Now for the building process, we use Azure DevOps to automate builds when commit or a merge happen. We also use Azure DevOps to implement multi-branch pipelines, which allow us to have multiple environments, each with its own source code, one for development, one for QA, and one for production. And we also use Azure DevOps to run agents both in-house with allied servers and cloud with AWS servers. And we also use Docker, which is a portable and distributed builds. It helps us to deploy code fast and in a portable manner, making it really portable and stable in every operating system or computer.
We included Docker in this build system part of the process because the entire application, the microservices and the frontend, all of them were containerized in Docker, and no local building was done in our computers. But everything was in Docker, and the local development environment was up using a Docker Compose, which got the microservices and the frontend up and running at the same time. and synchronized in their own virtual private network inside our computer.
Okay, so right now I'm gonna show you when and where these builds are running. Here we have the pipelines page from Azure DevOps, and these are our main pipelines. We have the infrastructure as code pipeline and also the front-end pipeline. And in this case, I'm gonna go into the development front-end. These are all of the builds. It shows when the build fails and when it succeeds. And to show you how it triggers, I'm gonna go here into the code. This is our code base for the front end. So here I have a view file, and just for showing, just for the purpose of the demo, I'm gonna go into this line and add a couple of comments. I saved it, and now I'm gonna go into the directory of the front-end project. Just gonna check which branch I'm in. That's the correct one. And add it. This is the commit, and now I'm gonna push it. So it's loading. I just pushed, and now back in the pipeline, I should see the job starting to run. So there is the job, and I can enter. That's the good thing and the useful thing about Azure DevOps is that I can go into the job and troubleshoot or see how it's going. So in terms of the build, these are the steps, and it installs Node.js, the libraries. It builds, and then it does the testing, which we're going to talk a little bit also in a moment.
So as Alejandro just showed you, we use testing, automated testing, which is really important to be sure that we're committing safe code and clean code. So we use Jest for unit testing and Cypress for end-to-end testing. Both of these frameworks were used on the front end. And on the backend, we use Postman, which is an integration testing tool that allowed us to test our backend through an API. And this was also automated, but this was done with Jenkins and not with Azure DevOps.
Okay, and the functionality of this part can also be seen in the same pipeline. So it's actually loading right now, and these are all of the console logs that it sends so that we can know what it's doing. Here in this part, it's just loading the project, but the first thing it does in the testing step is doing the unit tests, which we can see right here. These pass statements, all of them represent a couple of unit tests we defined in the front-end project. And once the project gets up, the Cypress test process starts, and it's running because Cypress is visual. It also does regression testing, and it is useful for end-to-end testing. So here we have the application running in the agent, and all of the tests are passing. And this also runs headless, because if you're going to run a Cypress test process in your computer, you're going to need a web driver or the browser to start. In this case, it's headless, and it all runs in the instance. And also for the testing, we have the Postman tests. I'm just going to move that this way. And the Postman automation and testing, it's useful for the API gateway testing. We have to test all of the different endpoints and all of the functionality that it's on the API gateway side. And as you can see here, we have the collection of calls we make to all of our endpoints. And here we have a couple of examples of the tests we do. The idea of these tests is that we are going to insert test data into the database, check that it's inserted correctly, make additional verifications, and finally delete it. So this is the couple of examples for Postman. And also talking about Postman, this is automated with Jenkins. And we can see here, there's a history of all of the builds. There's each number represents a build, and it shows if it fails or if it passes, so that before we push every change to production, we know if it's correct and if it's working properly. And here are additional metrics related to it.
So as we have already seen, for the release automation, we use Jenkins for the API testing automation, and also for the repository synchronizing automated automation. We also have seen the Azure pipelines, how we use it as a continuous improvement, a continuous deployment pipeline, because also in Azure DevOps we have the deploy to Netlify, which was a service that we used to serve our front-end application. And we have to say that the Azure pipelines are running in self-hosted agents. This means that we have our own servers in which we install the Microsoft agent for the running of the pipeline, instead of the Microsoft containers provisioned for the matter, because they have a limit, and after that limit, they begin to incur in constant costs.
Here we can check one of the pipelines for release management that Victor just mentioned. This is Megan Body, which is a leading software tool for pipelines and provides a lot of ready-to-use tools